Hello, everyone, and a huge welcome to this special session with Jeff. I'm Doris Hayam, and as the chair of the program for the World Mining Congress 2026, I'm really thrilled to be with your host. You already understand the challenge of our time. How are we going to deliver the critical mineral society urgently needs? We don't have 30 years, not even 20. If you have 10 years, how are we going to do it? This demands we radically accelerate discovery, get more out of our existing resources, and dramatically reduce project development time. The solution lies in changing how we explore, how we mine, and process. And before we introduce Jeff, I would like to hear from you. So we have a few polls to get a pulse on where you stand on this subject, and your answer will guide our discussion. So please take a few seconds and click your response on the Slido on the screen now. Calgary, USA, Germany. You have some from Stanford, Jeff.
hmm
So mainly USA. That's amazing. In Peru, less. Maybe they're a bit late. Chile. That's great. So all of these dots will be united on 24th of June in Lima, Peru at the Congress. So we can't wait to see you all. Well, India, Germany, Brazil, amazing. Let's wait a couple of more minutes to see where else. Maybe it's the ones who were on time with USA first, and then Canada, and then later and later. Excellent. Oh, this Colombia, Portugal. Oh, this is great. Nevada. Wonderful. Okay, I think, oh, look, keep going. BC, that's also from here. I think we can move to the next poll. This is give us a very good idea. Again, all these dots together in June 24 in Lima to celebrate ancient celebration of the sun. Thank you. At least we know who is in the room, where they are coming from, and let's carry on. And now let's welcome Jeff. Jeff is leading really a transformation, exploration, and moving to mining and processing. He's an academic, but he's all about action. Jeff is a professor at Stanford University. He's also the founder of Mineral X, where they have the conference that's just before our Congress. So we might see you there and in Lima. And is also leading the technical program for this World Mining Congress. So if you want to go deeper into this, we'll see you there. Jeff will speak about the future of artificial intelligence in exploration, mining, and processing of critical minerals. He will show us how to use human intelligence first and AI to transform exploration and, of course, greatly increasing the speed of discovery. Jeff, the floor is yours.
Well, thank you, Doris, and so great to see so many people from different parts of the world. I've been traveling this year a lot, and it's always a pleasure to see so much passion around this topic of the critical minerals we need to transition into renewable energy. And so, in this presentation, it's a short presentation, about 25 minutes. I will talk about a type of AI that you probably haven't heard as much about, but it's an AI that is meant to change systems. because I think in terms of accelerating and improving, there's many systems changes that need to take place. And so we have a confluence here in this time of our human lives where artificial intelligence, the great innovator of our time, is meeting the great challenge of our time, which is delivering upon those critical mineral challenges. And so I will start out with framing the problem and starting out from where I live. This is right next door here. I took a picture of a self-driving vehicle, which now in San Francisco, about 1 in 50 vehicles are self-driving vehicles. And these things work extremely well. They're very sophisticated. I think they're the most sophisticated AI that are around. And so we call this type of AI an intelligent agent. So it's an agent, meaning it acts in the real world and it tries to achieve certain objectives. But at the same time, it needs to deal with many uncertainties and can essentially resolve those uncertainties by several types of sensors. This AI works really well. As I mentioned, the numbers are coming out now and showing an incredible decrease in safety, increase in safety, and decrease in crash with severe injuries. So this is something that is very motivating, it's very inspiring, and so we'll look a little under the hood here of what this AI really is and how it is made and what it and how it can actually then be translated into what are we can do in the mineral supply chain. So from a kind of a bird's eye view, this AI is an AI that makes decisions. And let's say we are here on the road with our vehicle and we need to get to a destination safely. We have to take actions such as steering and braking. And our reward is then to get where we want to be in a time that's reasonable and also safe. To do that, we need to know the situation in the world or the state of the world, the environment that we are acting in, and that environment needs to be described accurately in order for us to take the actions that we need to get there safely. So in order to do that, we are taking observations. So observations, as you see in the self-driving cars, are various types of sensors, whether LiDAR sensors or visible light sensors. All these are being used to describe the state of the world so that we can take our actions safely. So these are the four components of the AI, and every AI I'm going to talk about in the talk around exploration mining are the same type of components. So we have to always look under these components. I call them the four buckets. Now, these four buckets, they logically happen together or they can live together in also time. So time obviously is a very important component into our world in exploration and mining. It's a significant challenge that we need to do things in time. And so the way we describe this AI is what we call a kind of a decision diagram, where we'll say, like in the previous step, we were doing some action, and that action has led to some kind of observation, right? So, and the goal now is to take the next action, but to do that safely. Obviously, you see there's a pedestrian in the road, there's other vehicles that are coming at you. And so, in doing so, I need to take action safely to get to the reward that I have, but there's uncertainties. We don't fully describe the state of the road. We don't have every single molecule described. We have just a description based on the observations that we have. That also means that, and this is a very important component, is that we have to optimize the observations as we are optimizing the system. And that's something I'll come back to a couple of times because this is what AI makes very different from traditional optimization. So once we do that, we continue and we go on and we go on. So this type of, as I mentioned, this type of AI is called an intelligent agent. It is a system that can plan sequentially tasks while facing uncertainty. And so the way these machines or these systems are trained is that there's a component we call offline training, which means training before we take any actions in the real world. And then as you drive, it's not just going to execute a task, it also has to adapt with what we call an online way. So there's a component of offline training and online adapting. So to solve these problems, to make this work, we need computers because the world is complex. It consists of many possible states. We can make many possible observations, and all of these together create what we call in computer science a curse of dimensionality. There is an infinite possible of actions you can take. For example, in about 10 years ago, DeepMind came out with a program called AlphaGo, which is a program that can beat humans in playing the game Go, which is Chinese game. Happy Chinese New Year. And so in this game, we have as many more possibilities on the board than there are atoms in the universe. And so in order for us to plan optimally, we have to solve a problem where we search in this kind of space for the best solution possible. So every time we will talk about using the AI, we are actually doing significant computing, which is something that the mining industry is not necessarily used to. And so that's something to keep in mind. Okay, so the key message is that an intelligent agent is an AI for sequential planning under uncertainty, and it's not just a tool, right? We think of AI sometimes as a tool that does something. We take some data, we put something, and make a prediction, we make a map. This is an AI that makes decisions while it is taking data. So there's like a whole system that now comes together about decision uncertainty and often with conflicting objectives. Okay, so I think we all agree that planning well is what we need to do when we think about critical minerals and the supply chain. And so that starts with exploration. So now I'm going to take that same diagram and I'm going to turn that into an exploration diagram. And so in exploration, what we do is we acquire data. Once we acquire data, we can now say something about the real world, means our subsurface geology. And we can take then the next action about the next data we should be acquiring. So we can see exploration as a sequential planning of data acquisition, whether you take geophysics or geochemistry or drilling. The goal here is not to say find mineralization. The goal at first is to reduce uncertainty on the nature of the subsurface. And so this is a very different approach to exploration than typically is done, where we just kind of drill one borehole at a time and then we see what happens. Now, there is a difference here, and Doris pointed it out, is there humans are still very much needed. And actually, humans become more important because humans in the system are going to have to make hypotheses about the subsurface. What could be there? What is the style of mineralization, etc. So the first time we applied this technique, it had great success. This was the discovery that Cobalt Metals made, who hired the student who implemented this type of AI at Mineral X and applied it to drilling for a copper deposit in Zambia, which is a significant resource. The way the drilling was done is very different from actual drilling, and I'll show that in a bit. But the key point that the AI did was not to drill to determine grade, but to drill to falsify human-generated hypotheses. Because you can imagine if your hypothesis about the subsurface is completely wrong, then your drilling will be extremely inefficient because then you're constantly chasing what the real answer would be. So we start out not with, say, one model of the subsurface, but many possible models of the subsurface. And then we aim our drilling to reduce that uncertainty. So what does it mean in the copper belt? Because this is in the copper belt, is that we have to, number one, we have to work with the best geologists on the planet that work in the copper belt because they have a good understanding of how these copper deposits were formed. And so that formation of these copper deposits in very sort of 10-meter, very extensive layers in what we call an ore shale is essential to understanding that. So the way it works is that we do not build a single deterministic model of the subsurface that models the grade, but we think about how we represent uncertainty as hypotheses. And so when you think about these copper deposits, as I said, it's a thin layer that is very extensive. You see here many, many kilometers that contains oxides and sulfides, and they occur in certain domains that are controlled by certain geological features such as faults or geochemical alterations, we have to really think about what the style of that mineralization can be. And so when we interacted with the humans, we asked the humans for high-level hypotheses about where could the oxides be, where could the sulfides be. And from those, we created many models that could represent the copper grade in the subsurface. And so you see that if you have one style of domaining within the subsurface, you can get many possible models of grade. Now, the geological hypotheses, I mean, the top picture itself is uncertain. So if you ask another geologist to draw such picture, they will draw something different. So this is what we call geological uncertainty. The hypothesis completely changes, and if the hypothesis completely changes, then the grade distribution in the subsurface changes completely. And so we can keep asking, and we came coming out initially with 8 different hypotheses on what the subsurface could look like. And for those, we can generate thousands and thousands of possible models of the grade distribution. You have to juxtapose that to what people do today is they build one single model, right? So if I show you that one single model and I ask you, where would you drill next? It's not, it's a very difficult question to answer because there's not really a metric to say where you would drill next. Maybe you drill in the high grade, or maybe you drill in the low grade. Here we are going to drill to reduce uncertainty on what the humans think the subsurface looks like. That means like one of these top pictures, there are 3 possible here. And so we're going to try to drill such that we can falsify as quickly as possible any of these hypotheses and land on the leading hypothesis. So here's then, of course, the actual implementation is in the real world. This is in Zambia, and this is basically one of the first boreholes that was drilled there, and AI was used to determine the location as well as the angle at which this borehole was drilled. So I'm saying these are real investments, right? So this is $1 million boreholes because in the copper belt you have to go to about 1,500 meters deep. So this is a substantial investment. Now let's talk a little bit about this drilling worked. So here on the left-hand side, you would say this is typical drilling in the copper belt until now. And so you see all these dots on the left side are all drills. And so typically people would say, oh, we have to drill on a grid. And once we drill on a grid, we have to drill and fill in that grid such that we can reduce, we know as much as possible of the resource. So that's not an efficient way of doing because you're really using information of the previous drills to determine what's the best location of the next drill, right? It's like playing chess one move at a time and not thinking about the next 10 moves. Obviously, you're not going to win. So the way we do it here is that we're going to drill, as you see, the drill moves around seemingly random, but that random is not random. It is with the goal is to, on the right-hand side, is to reduce uncertainty on your resource, such as grades and tons, until, as you see, you come in a point like here where you're above or below a certain economic cutoff. And then you can say, if I'm below the cutoff, I walk away and I go drill somewhere else. So I don't keep on drilling and when I know that I will never get above the economic cutoff. So this way of drilling is very different, obviously, but it is highly effective. In our calculations, it can reduce drilling by a factor of 5, which is significant. Obviously, it's not just money spent, but also time spent on doing things. Okay, so now where else can we go? Now we can say, yeah, but it's not just about drilling, it's also about sustainability. It's about the environment. So how can AI help here? Well, here we work with an unnamed company who has 5 possible economic deposits that they would like to develop in Brazil. And so obviously you also have issues related to distance from indigenous population or ecosystem conservation units, etc. So how would you make an optimal decision now around developing these 5 resources while accounting for all these other factors? And so these other factors are now conflicting objectives with regard to the development of the resource. Obviously, the best way to do is not develop anything, then you will not violate any of these factors, but that's not an answer. So how would we, over time, develop these resources? Would we prioritize target result one or two, and when we start two, and when one? And how can one inform two, etc. So this is a system that can be solved using the same AI as we did with the drilling. We have a reward, which now includes some ESG standards. We have actions, which is either more exploration, mining above ground, mining underground, and abandoning. And then we have geological uncertainty. And so when you do that using the same AI, you can get an answer that is much more favorable than an answer you would get by standard economic optimization. And here you see for this case, the predicted cumulative cash flow for these five deposits compared to standard economic approaches of uncertainty of planning. And so we see that actually planning with the idea of ESG in mind gets you a higher NPV because you're avoiding costs such as litigation or project delay that are coming when you start developing in an area you shouldn't be. And at the same time, you can honor some of your ESG standards. So why is this better? Well, because in the future we'll get information, right, that will reduce uncertainty. And that fact we can use today to make better decisions. So we don't see decision making as what we call a one shot, a myopic application of a plan. No, it is a plan again that has offline learning, but then also online adapting. You will adapt to the situation that you get, and that is the reality, of course, on the ground. So let's move now to mining and specifically looking at some important applications of AI in the mining world itself. And so one way to think about that or look at that is look at the oil and gas industry. So I've worked for 25 years in the oil and gas industry, and the industry has very much adapted AI-based approach for extraction. And so their eternal return investment is much higher than of the mining industry. And so you could wonder, okay, what are some elements from the oil and gas industry that we can borrow that we can apply to the mining industry? And so one of these things now, thinking about developing that mine in Zambia, the one that we had just earlier drilled, we're now in the area of mine planning. And so big problem of mine planning in the copper belt is water. There's too much water. In fact, that mine, the Concola copper mine, is the second largest producer of water, essentially in every single mine in the world. You see that there are rivers literally in the subsurface. And so dealing with that water is important to make the mining effective, but also to think about contamination, obviously, of the groundwater system. So what does the oil and gas industry do? The oil and gas industry, and we're using here oil and gas platforms, is going to build thousands and thousands of models of the subsurface. You see here the layers. It's going to then evaluate on those thousands of models what are possible scenarios of dewatering. And then because we have quantified uncertainty, the AI can then decide what is the optimal combination of where you put watering wells in order for you to drain the water down in below the resource. And so that can all be planned and evaluated. In addition, you can evaluate with this what kind of additional data you should be acquiring. Because obviously to do dewatering, you have to acquire data about the pressure and the flow of water in the subsurface. And so the AI also making recommendations in that regard. Okay, so moving on to processing. Processing, again, if you think about it, this is for cobalt. Processing is a very complex chain of events. And so if you can see processing as a system, then you can imagine optimizing the system. And so optimizing the system becomes relevant when the variability of the material you're trying to process is variable, right? We know that things in the subsurface are not constant. Not only is the grade not constant, but also various geometrological properties are not constant. And so that variability needs to be quantified, but then that variability needs to also be addressed while optimizing the processing. And so to do that optimization here, we work on project on frost flotation optimization in our group. We're looking at optimizing a system, right, the frost flotation, knowing that there is uncertainty in the feedstock and knowing that there's uncertainty around the dynamics of the process, right? We don't fully comprehend the process. It's a very complicated process. So if you have feedstock uncertainty and you have process uncertainty, how would you optimize the system? Well, we would have to collect some information, right? We can put sensors in, we can measure the recovery and the grade, but then the question is how much should you measure? Right? So an AI is something that optimizes both at the same time. It doesn't say, oh, let's get some measurements and then optimize the system. An AI will optimize the amount of measurements you need to take, as you see here in the bottom, such that uncertainty is reduced in such a way that I can now optimize the system. It's the same as the self-driving car. A self-driving car is not going to take data first and then worry about taking the actions. It has to take actions and data at the same time. And so combining these together, the only approach to solve that is the same approach as we use in the self-driving car. So if you think about the software that we're using, the software we're using has not changed from the slide of the drilling in Zambia to the slide here on the process optimization. These are all the same software. It's just about reformulating the problem into a way it can be solved. And then finally, a very exciting new project we're working on is if we can do this for individual processes, how about we can do this for the entire supply chain? Because as you know, the supply chain today is very much cut up into various pieces. Lithium is mined in Australia, is shipped to China, then back to Australia, and then goes to the United States. So we need to reorganize the supply chain. But the supply chain is a plan. If you think about it, right, it's a step of actions we take in the real world, but there are several uncertainties. These uncertainties are geological, they are economic, but they're also geopolitical. And so now we have to optimize the system under all these various uncertainties. And some of these uncertainties are not trivial. And so we were approached by Toyota on a project because Toyota, as a car maker, is very worried about sourcing material. And so they're saying, where should we make our investments? Should we invest in Peru? Should we invest in the United States? What should we be doing? And so assessing the risk associated with these investments is essentially assessing the risk of your sequential plan under uncertainty. And so there we are using new types of AI where we get what we call what if questions, right? If you think about geopolitical uncertainty, you can ask, what if China invades Taiwan tomorrow? What if Russia invades Poland tomorrow? What does that mean for the supply chain? So we need to be able to quantify those uncertainties, and we need to also be able to quantify the effect of those uncertainties. And so large language models, in fact, are new forms of AI where we can extract causes and effects. And those causes and effects can then be put into our AI optimization tool and can help a decision maker or an investor in making informed decisions rather than, hoping and wishing what it can and could be. So this is some really new stuff. It's very exciting, and it's something I think is very impactful. Okay, so if you want to read a little bit more, there is actually a report I wrote with the Cobalt Institute. It's a very high-level report, so if you want a very non-technical explanation of what I just did, that would be that one. And then there's two papers came out recently about the future of AI in mineral exploration and also some AI-driven optimization in mineral processing. Okay, and with that, I'll end here and take your questions. Thank you very much for listening.
Thanks, Jef, for this inspiring talk. Just before they're formulating the questions, and in the meantime, maybe we just go with a couple of questions for you. You talk, it's all about decision making.
Mm-hmm.
So what about countries that are spending a lot of money, Canada, South America, Africa, to do their geological mapping? And so what problem are they going to encounter in deciding where to drill after having all of this information, all this expenditure? So where you see the problem and what they should be doing, especially for the countries that may be starting to build their geology?
Yeah, so well, for countries like Canada, it's in Australia, it would be more about managing the conflicting objectives, right? As I say, there is the issue of getting the material we want, but at the same time not destroy the earth in doing it. And so seeing the problem as consisting of many options, like a set of portfolio of resources you have, like in the Brazilian case, can help you balance the risk and the uncertainties, and that helps you mitigate some of the problems. For countries who are just starting out, I think the first order of business is data and digitization. There's no good decision to be made without any data. And so, if you look at countries like the DRC and Zambia and the Copper Belt, there's still a huge, a challenge around digitizing. Number one, digitizing the information that's existing in the reports because not digitally available. And secondly, if you look at Canada is about 100% or 95% of it is mapped with geophysics. The DRC is only 5% is mapped with geophysics. So we are still at the early stages of needing to acquire that data. But what's going to be really important for those countries is to make that data publicly available because that is what's going to create the investments that we need. And we see that in Zambia, right? In Zambia, the Geological Survey has now made reports publicly available. You can go online in their survey and download reports. And we also see that in the last couple of years in Zambia, the year over year, the investment increase in exploration has been 100%. So it really matters. The DRC is still beginning in doing that and still has to catch up, but there's of course incredible potential there as well.
Thank you. So for those countries who are starting, get all your data from your files, from your
Yeah.
dusty files, and start digitizing
Yes.
before jumping into AI.
Yes.
So
Absolutely.
I think the lessons we have to really understand what we want to do, formulate our own hypotheses before we jump into AI. So another question, the focus for the Congress is getting more out of what we already have
Yeah.
and reducing project developing time. So can you share a specific example on how AI has delivered a quantifiable improvement in either of those key areas?
Well, in the mining world, it hasn't because it hasn't been applied. But if right, we're at the beginning. Uh,
Or what could
so
be possible?
yeah, so in the oil and gas world, it's definitely been applied. So what happens in the oil and gas world, if you look now 25 years ago, people were building a single model of the subsurface. They were planning their production wells based on a single model, only to find out that when they drilled in the subsurface, there were faults they didn't know about. And so faults are a big issue for fluid flow and oil and gas production. So then they drilled another one and found some more faults. So the whole point was that they saw that quantifying uncertainty and building many models is really what you need to do in order to assess any kind of risk associated with that. So that's number one. So we need to go from this single model to the multi-model. But the multi-models are not just there to quantify uncertainty, they are to improve decision making. And so you can see decision making as drilling one well at a time, well is a borehole, or you can see decision making as planning a series of wells. And so we see now an uptake in the oil and gas industry around techniques like reinforcement learning and the type of intelligent agent that I've shown here with great benefit. And I think one of the areas where we see application of this is in the shale production world, right? Shale gas, shale oil, where people have to drill boreholes, but very smartly horizontally. And so they do their steering of that borehole using sensing and using AI to do online adapting. And so all of this technology is just readily available to the mining industry. You could say, well, that seems like a big cost and a big trouble to build multiple models, but there's a bigger cost in say, well, I start sinking my shaft and suddenly I have 100,000 liters of water per day. And then I have to worry and I have to go to investor and say it's going to take 3 more years. So that's where the real cost is, right? And that's something we always have to keep in mind.
Great. So just a last comment. So moving from single model to multiple models, and I guess different business models, sequential drilling.
hmm
So how does that impact going from high risk, low reward to high risk, high reward?
So so high risk, high reward. I think one of the problem in the industry, if I have seen coming back into the mining industry, is that you can do high risk, high reward when the industry is made up of junior mining companies. They all want a high reward, low risk. But of course, the real situation is it's not like that. So can you imagine that we could say, let's take the 10 best junior mining companies, let's say put them all together in one investment fund, and the investment fund can now start deciding on where to give the money and how to do that relative to, of course, the outcomes that are going to happen in terms of the drilling that they're going to do. That's much better than taking individual companies who are making individual decisions on their resources. Their motivations are much different than the motivation, let's say, of an investor who can take 10 of these companies and wants to maximize the NPV of all of these companies together, because then you can balance risk and reward, right? So you can say, oh, this is more reward, more risk, and this one is low reward but low risk. So you can now start balancing that out. Right now, that is not done in the mining industry because of the nature of how the industry is organized. So I see a lot of uh, kind of ways forward to new investment models that need to come out in order to do this exploration.
Then we have to reorganize first.
Yes.
All right, systemic change. So thanks, Jeff. Now let's hear the floor. So maybe Guillermo, please show the questions from the floor so that we can address them. He was already running the questions. So which ones have more votes? Usually you can see the number.
No
So
one has
I guess
votes.
the one on
No
top,
votes.
right? Can you see it? The ones on top? So go ahead, Jeff, pick
Yeah,
some.
so the environmentally refining, that's what I started to looking into, right? Is number one, there is the efficiency that comes with better understanding the variability of the material, including contaminants, arsenic, cadmium, and so on. That requires measuring things. That's number one. The second one is a project that we're also involved in is in developing better chemistry through better reagents. A bit like in drug discovery, we can discover drugs that work for certain diseases. There's also ways, I believe, to use AI to discover reagents that are better at processing the material. So there are a lot of low-hanging fruit there. I think the system integration is the simplest one, and then we can go into to these other ones. Um, how can we verify that AI-driven models actually produce optimized plan if the data used for training? Number one, absolutely right. So the data quality is really important. I should mention though that in the kind of planning that we talked about in Zambia, there was no data, right? There was very little data because you are in an area where you're either exploring or you're just on a brownfield situation. There's almost no drilling or no drilling at all. So it becomes more about training uncertainty, right? Is to build sufficient amount of models such as the system can understand what the uncertainty is, and then the consistent system can plan to reduce that uncertainty. So it's more if you don't have realistic uncertainty, you'll have not realistic plans, and the plans will be optimal. So that's something to take that into account. Um, so for implementation, how does AI handle the resource terms without extensive? I think the what we're hoping to see, and then you here in San Francisco, you hear a lot about AIs replacing jobs and stuff like that. I don't believe in that. I think AI is going to augment humans' capabilities, in particular in geology. Geologists do a lot of work, like manual interpretation, manual data handling, building multiple models. All of these tasks can be done by AI. The task that cannot be done by AI is the creativity that you need to come up with to create multiple geological hypotheses. So the creativity we still need, right? Your experience, your creativity. For example, in Zambia, as I mentioned, we had a situation where we had to determine where the graben structure were. They were important for the thickness of the formations and where the geochemical alterations were. And so those things, how to come up with that is something that's more based on experience. So I think AI will more will help geologists in doing actually more useful work as opposed to repetitive work. So AI reshaping the skill, yeah, absolutely. I mean, academia is up for a completely overhaul today with large language models, with AI. The way we're going to train people is going to be very different than the way I was trained or Doris was trained, and even people, that are millennials are being trained. We're going to have to focus it very differently and embrace AI as a way to, as I said, to do things faster. So I think that's one. The biggest bottleneck I think is in that the mining is, as I mentioned in the one slide, is that there's a conservative view on uptaking new technologies. And that conservative view is not there in oil and gas industry. So I think it's a matter of changing that that kind of mentality and view. And what the way that's going to happen is not by changing people that are not going to do that, is by new companies that are coming in the world of this in the mining world, because the last three of my students all started a company, while the three students before that were want to become professor. So now they're all starting a company because they think AI is great, mining is important. So they're trying to get their skills. So we're seeing an influx of young people, and I think that's what's going to change things like that.
So the disruption is going to come from outside,
It's going
not
from
here.
absolutely, yeah. The disruption will come from outside.
Maybe take
So
one more, and then we go on to polls.
Okay, yeah. According to LLM, so we are using Claude, and we're doing what we call RAG, which is a type of LLM where you can train on specific documents. And these are also RAGs that LLMs that can extract knowledge graphs. So, for example, imagine, say, what if China invades Taiwan? It's a question that we're actually modeling right now, and so you would need to extract what is near Taiwan, the Strait of Taiwan, what the shipping is, and so on. And so all of that information can be extracted from text, right? You don't have to go and write that up and program that yourself. So that's where we also see large language models having a huge advantage.
Excellent. So I think then we have a couple of polls. It would be good just to check the polls
Mhm.
a little bit of your impact, Jeff. So,
Uh-oh.
Guillermo, can you throw those two polls, please? I think you have to activate it or something.
Yeah, it's not activated.
Yeah,
There we are.
I don't see it there. Oh, they're starting. Wow.
That looks good.
You did a good job. Okay.
Uncertainty. Yeah, absolutely.
We need to focus more. Excellent decision. Yeah, very good. So, are you okay? We move to the next one, the next poll. One more poll, and then let's see. So we'll continue the discussion at the Congress. What's the number one reason you like to join to see our tools in action? So Jeff, tell them what they will
All
see
right.
at the Congress.
Well, at the Congress, we have definitely we had a huge amount of submissions for the artificial intelligence, so there will be a big attention giving to that. I will also run a short course. It's more at a high level short course around what are things you can do immediately in a company to integrate AI tools. We're not necessarily going to say, oh, here you can run this in Python or something like that. I think, I think it's important to start out with the bigger picture. Although we have some other courses, I think, right, Doris, that will
Yeah, we
bring
have many.
these topics. It's very exciting. It's a very exciting program, and I look forward to meeting you there.
Yeah, and the biggest was to network with the global leadership in this.
Yeah, we have
Yes, definitely.
an amazing plenary forum, Doris. Maybe you can talk about that a little bit.
Yeah, we have all the decision makers who are leading change, the CEOs of top companies around the world. investors, and we're really thrilled with the response, with excitement. Yes, you will definitely, but also you will join this transformation because we will be focused on actions and we'll take those actions and measure progress over the next 10 years. As I said, we don't have 20 or 30 years. If we have 10 years, how can we get more of what we got and reduce project time? So join us, be part of the change, and we can't wait to welcome you in Peru. So first, thanks, Jeff,
Thank you, Doris.
and for this inspiring session. So for a more intelligent future, of course, and you cannot miss this Congress that's coming up to go deeper. We are gathering the brightest minds to tackle the challenge of this decade head on. So don't just watch the future unfold. Come on and help us build it. Time to register is now. And thanks again. And we have a few words from Abraham. Is Abraham here? Abraham, just a few words to close this session if you're there. Abraham is the president of the Congress, and you are muted if you can. You have the floor.
Oh yeah, thank you, Doris, and thank you, Jeff. It was very inspiring and a great speech. And again, this is an example how artificial intelligence will change and reshape our industry. Very interesting your points, especially how this was applied on the oil industry and how can we take advantage in the mining industry applying this kind of technology, reducing uncertainty and really help us. And in fact, thanks again, and thank you, Dori, for the great initiative. I think this is a very good example of what will happen in the World Mining Congress that will be in Peru next June. And let me tell you that not only Peru has a very long tradition, it's a mining country, and we will be more than happy and welcoming you in this Congress. Peru was hosted this event back on the 70s, and now in 2026 we will do it again. As Dora explained, with the three T's, we need to transform to trust using technology in our industry, and I think Jeff gave us a very good example what this means. And Peru is wonderful. We already are arranging for you guys some trips that you will enjoy, and also the opportunity to see one of our biggest operations, of course, Machu Picchu. That is lovely and amazing. And also, this event is linked with the Inti Raymi, that is the sun festivity here in Peru. That will be amazing. I think it's a great opportunity to be all together in Lima, and we are waiting for you. Thank you, Jeff, again. It was really inspiring presentation. Thank you very much. Thank you, Dori.
Thank you. And we look forward to seeing you all at the Congress. I think I just want to elaborate on Abraham. The ancient celebration of the sun reflects new beginnings. So for the whole industry to start afresh and be the solution to the future. So let's join forces and just do that. Thank you.
Thank you.
Guillermo, is there anybody who's dying with a question or anything? I think anybody saying anything in the chat? So we have a few minutes if anybody wants to.
Yeah, I will share it. What is the dream outcome? What do you envision as the future of this technology applied to mining?
So somebody's dying to get an answer, Jeff. After we close.
What is the dream outcome? Oh, okay.
That's not bad.
Well, the dream is, that the AI is democratizing everything, that nobody's going to get an advantage. Nobody has like their secret sauce in their closet, right? We're putting everything online available. The drill algorithm that Cobalt Metals used, you can download from our website. We're going to the DRC and built with the government a large language models to be able to interpret, their documents. But that model itself that we're going to build and how it's done is going to be open, can be available to everybody, right? And I think one of the great things about here in Silicon Valley is that a lot of the things that were that developed, right, like the internet and the Google Chrome and all that stuff is just freely available, right? And that is a way to democratize things and not have people have advantages over each other. And I think that's what I hope. Of course, there may also be bad actors, but I hope the good actors will outperform the bad actors.
Wonderful. That's a wonderful place to end. And also, if you really want to publish a paper, we pass the time of abstracts, but we can open a little window for your voice. If you want to write a paper, you can still do it, extended abstract or paper. And Jef is the one who is going to publish a book with all the proceedings, with all our voices. So if you like to do that, you can still do it. So contact us and we can get you in touch with Fabricio, who can help you to do that. Thank you, everyone, for your time. Thanks, Jef, for this amazing time. Thanks, Abraham. Thanks, Guillermo. Thanks, everyone. And have a wonderful day.
Thank you. Bye-bye.